Okay, hello. Welcome to Algebra Lesson 2-8. This is going to be about proportions and similar figures. Proportions and similar figures. All right, we're going to go ahead and get started right away. Let's start out with our anticipatory set, as we always do. Now, as a kid, one of my favorite things to do, I loved jets. Planes, any kind of planes really at all, but really military jets. I was all about it. I got all excited about them. I knew every single one of them, and I would collect little model planes, I guess you could say. And by as a kid, I mean yes, as a kid, but also yes, today, these days. I love collecting those little jets. Too bad I'm not in my apartment because I could definitely show you. I have a couple sitting there on my desk. It's always nice to have those things, but I always loved that as a kid. And the thing I loved about them was that they looked so similar to the actual jets that I saw, pictures of, and video of, and things like that. Now, if you've ever gotten one of these kinds of jets or gotten any kind of model, really, you know that for the most part they look similar. But for some reason, kids' toys, for some reason, don't exactly look exact. They think you want these little extras. So the thing I liked was how sort of sleek these jets looked. And remember, Mr. Barry is not an artist, so this is not going to be, it was sort of like, all right, oh boy, this is going to be terrible. Sort of. Okay, so it's close enough. So the thing I liked about collecting these sort of jets was just how like sleek they looked. My favorite, and this doesn't look anything like the jet that I liked, but was the FA-18 Hornet. It was my favorite. My favorite plane. And it doesn't look anything like that. It actually looks totally different. If I was in my apartment right now, I could totally show you a little model I have, but it doesn't look anything like that. But for the purposes of our anticipatory set, I'm just going to say it. Now, the thing I liked about these jets was that they looked sleek and they were very aerodynamic. I really liked that about them. Then when I would go to a toy store and I would try and pick out my new favorite jet, a lot of times, and I'll try and draw this again, they would have the jet, it would be there, but I would always hate the way that the toys sort of made them look because I don't know which people like it better this way, but for some reason they had a perfectly good jet right there, and then they put this gigantic wheel on it. I'm sure you've seen things like this before. There'd be a wheel in the front. It'd be one of those where you pull it back, and then it would sort of drive along the ground on its own. I always hated that. I tried, whenever I got a toy like this, I would try and break this off. I would wiggle it around until I could try and snap that wheel off. Because I didn't like that. I just liked the way they looked. I like looking at the different kind of sleek jets. None of these jets don't have these giant wheels. They're not cars. It always bugged me. Still bugs me. I always want to get the ones that look exact. And that's sort of what we're talking about today. So let's go ahead and get started with our lesson. And we're going to start with our standard. And there are two of them today. Two that we've sort of been using before. We've been using these quite a lot throughout our chapter 2 so far. And the first one is A-CED.1. All right, and what this states is that we can create equalities and inequalities in one variable, or that means using that one variable, and use them to solve problems. Include equations arising from linear and quadratic functions. And simple, rational, and exponential functions. Now, we haven't quite gotten to the exponential functions there, but for the most part, we're covering this again, creating those equalities and inequalities. We now know how to solve them. We're getting very good at that. And let's move on to our next one, which is A-REI.3. This one's a little shorter, so that's nice. And this one says, solve linear equations and inequalities in one variable. Including equations with coefficients represented by letters. Okay, so there we go. Those are our two standards for today. And you can see we have been working with these before. I think even the last couple lessons have been working with this. We're creating equalities and inequalities. We're using that one variable, and we're using these things to solve problems. Okay, and then here we want to make sure that we can even do that when the coefficients are represented by letters, and that makes it easy. There's just no numbers to deal with. Normally, that's solving some sort of a formula. Okay, so we're going to get right on into our input. I'm going to start with a few language of the discipline. Oy. Oh well, still not good. All right, our first one is, let's use a different color. Our first one is similar figures. Similar figures. That makes sense that we're figuring out what that is because it's written right up here. Similar figures. And what similar figures are, they are figures, obviously, and they have the same shape but not necessarily the same size. Okay? So these are shapes, these are figures that look the same, that have that same shape, but they're not exactly the same size. We can go ahead and get an example of this down for you. An example of this could just be, let's make sure I'm doing this right. One triangle that looks like that. And then another triangle that looks like that. Now those, I drew them, and with the graph paper it makes it a little easy. As you can see, right on this side, 1, 2, 3, 4, 5. This one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's double, meaning that's double, and this is double. So these two shapes look the same, but they are not the same. They are only similar figures. So we can label each of these angles here, A, B, C. Let's do something different over here, F, G, and H. And now the way we write this, the way we show that these are similar, is that we draw a little triangle. And then which triangle are we talking about? We're talking about ABC, triangle ABC. And then the way we write it is this squiggly little line. And that means is similar to, and then you draw the triangle again, and you look, and we have to do in the same order. FGH. FGH. The reason that these are similar is because of our angles. Now look at each of our angles. If we look at angle A is the same size as angle, which one over here? F. They're the same, right? They're the exact same. It doesn't matter how long these go off, they go in the exact same directions for exactly the same angle. So the way we write that is that we write a little angle A, and then you draw this symbol. And what this means is congruent to, which means it's exactly the same as angle F. Angle A is the exact same as angle F, is congruent. Then we can say angle B is congruent to angle G, and angle C is congruent to angle H. So that's how you know a figure is similar. If the shape is the same, doesn't matter if the size is the same. Size can be different. Imagine you are looking at this and then you zoom in a little bit. It could look exactly like this. We're just dealing with the size. All right. Now we have one more, and we've seen this next term before, but I want us to at least write it down and put a little example with it so we can remember, because we're going to need to. And this is the cross products property. We should remember what the cross product property is. We've used it even last year, 7th grade. And what the cross products property says is that if we have something like A over B is the same as C over D, then we know that this times this and this times this is also equal. So we can also write this as A times D equals C times B. So it's the same thing as saying that. Okay, so I'm out of room here, so we're going to move on, but that's what you need to remember about our input. Now, as we move on here, it's ripped. That is frustrating. Hate that. All right, let's go ahead. Since there's nothing else we're going to need to do with our input, all we need to do is know those terms. We're going to get right into our modeling. All right, in our modeling, we're going to start off, obviously, with number 1. And number 1, I'm going to go ahead and draw 2 triangles. Now, these triangles are not to scale, but I am going to label their sides with different distances, okay? So just go ahead and stick with me here as I get this. We'll do that, and then we'll do... All right. Now, those are not to scale, so they may not be perfect. They actually look pretty good, though. I'm pretty happy about that. And then I'm going to label the angles. A, B, C, D, E, F. So those are our angles. And then over here, I'm going to tell us that triangle A, B, C is similar to triangle D, E, F. So now that we know, even though they're not drawn to scale, I know that these are similar, meaning the angles are the same, but their lengths may not be the same. Then I'm going to go ahead and fill in some distance or some lengths of the sides. For this triangle, I'll give us a 3 there, give us a 5 there. Here I'll go ahead and put a 15, and then this is going to be X. You know what, I'll even fill this one, 5.83. Okay, now, if we're looking at this, we need to solve for X. We need to figure this out. Now, I only have one length on this triangle, but that's all I need because I have this similar figure that I have all of the measurements for, and we can use proportions to figure this out. So the first thing we need to do, first step, is to write a proportion. Okay, and to write our proportion, we need to see how these sides match up. We know the angles match up, but how do the sides match up? Well, I know that A is the same as D, C is the same as F, and B is the same as E. So the length here between A and C and the length here between D and F are going to be related. So we're going to go ahead and say AC over DF. So they're related. The length of AC over the length of DF is the same as the proportion, the ratio between two other lengths, this length and that length, we could say. So we could say it's the same proportion as BC over EF. So now you can see that we know that these are similar figures, meaning that their proportions need to be the same. Their sizes aren't the same, but their proportions are the same. This is related to this in the same way that this is related to this. Okay, our next step is to substitute. And we need to substitute the things that we know. Now AC, we know that AC is this 3. We have that. So let's go ahead and write 3 over, now what's DF? DF is also known, and that's 15. That is equal to BC. We do know BC as well, over EF. We do not know EF, but we have a variable. Now we have that one variable equality that we have right there, which we should be able to solve for. That next step is going to be to remember our property, which is the cross products property. And now remember, the cross products property tells us that. Go ahead and do that. So we now have 3x equals 5 times 15. Perfect. Then we can go ahead and simplify, which will give us 3x equals 5 times 15. You can go ahead and figure that out, but it is 75. Then we just need to continue simplifying. We need to isolate that variable. Divide by 3. We divide 75 by 3, giving us x equals, we should all know 75 divided by 3 is going to give us 25. So this missing length right here is 25. Now, the same way you can do this is just one with variables, but imagine, and there's a good example of this in the book, so you can check it out. But if a person was standing here, and the sun was hitting them and creating a shadow, and there was a building right here, well, a tall, skinny building at least, and the sun was hitting it, going right here, and you knew these same things, you could figure out the length, the height of the building by looking at these triangles, right? So there's a good example in the book of that, but you're just solving for what you do not know. All right, let's go ahead and look back at our anticipatory set and see if we can figure out a way to look at that there. Now, I always used to collect the small jets, right? The small little models, but there's also some pretty awesome ones out there, and I always wanted one. So I'm going to pretend for this problem that I had got one. I never did get one, but I was always excited for it. So my awesome scale model has a proportion of 2 feet to 24 feet. And now, if you've ever had a model, you've probably been able to flip it over or look somewhere. I always used to find them on the little wing right there. It would always have a proportion, tell you how big the model is compared to your actual vehicle, whatever the actual thing you have a model of. So in this case, in the case of my awesome scale model, I'm going to say that the F/A-18 Hornet has a proportion of 2 feet to 24 feet. Okay, so that means that 2 scale feet is the same thing on the model as 24 real feet. And then if I went and this awesome model and I measured it, and let's go ahead and if I measured my toy, or my model, it's not a toy if it's this big, at 5.02 feet long, how long is the actual jet? Okay. So when you look at this, a lot of the problems when you're looking at some of these sample problems you're going to be having have images with them. You look at the images. But remember, we're just looking at proportions. We don't need these images. You just need the proportion. So that's what we're going to do with this. I haven't drawn out the plane. I haven't drawn out the model. You're just looking at numbers. So if we look for the important parts of this, we know that there's a proportion. I write the proportion twice here. All right, so we just need to know what that proportion is because that's going to give us the ratio we need. Then I know how long my awesome model is. So really we're only missing one thing, which is the length of the actual jet. So the first thing is, as we did above, we need to go ahead and write a proportion. And to write this proportion, we're going to need to know, first of all, what is the ratio? And that is, it tells us right here, 2 feet over 24 feet. So that relationship is the same as, now which one is the model? The model is the top, the numerator. So the model length is going to go on the top. What we don't know is the length of the jet. Now we just have a problem to solve. And the next thing we do is the cross products property. The cross products property tells us that this and that can be written. So we can say we now have 2x equals 5.02 times 24. All right, now we need to multiply. And there's no shortcuts in math sometimes. So we need to make sure that we actually multiply. 5.02 times 24. We multiply. We have to move our decimal point out, save that for later. 4 times 2 is 8. 4 times 0 is 0. 4 times 5 is 20. We drop our 0 placeholder. 2 times 2 is 4. Oh, you can't even see this. So sorry. 2 times 2 is 4. 2 times 0 is 0. 2 times 5 is 10. 8, 4, 0, 2, 1. We take our 2 decimal points, we put it back. So now we have 2x equals 120.48. We need to isolate our x and divide by 2 here, divide by 2 here, which gives us x equals 120.60.24. So the actual plane, the actual Hornet that I'm talking about is going to be 60.24 feet long. And we've solved our proportion. We didn't need an image on that one. We didn't need a chart or a sign or a picture, anything. We just needed the proportion. And that's everything. That's all we need to work on for today. I'm going to go ahead and give you your guided independent practice. Enjoy your short week. Your guided practice. Your guided practice is going to be the PPSE in the book, and you're going to do number 6 through 18 even. We normally do odd, but today we're going to be doing even. 6 through 18 even, and that's it. And then your independent is going to be your 2-8 quiz. All right, and that's everything for today's lesson. Good luck, have a nice day, and go Buffs.